we're still going to be working with 45, 45, 90 triangles, but now we're going to do the application. So Andre is building a structure that is out of playing cards. Each card is 6.3 centimeters long. So they already made a picture for us here showing us how he's, oh, whoops. Why does it keep doing that? 6.3 centimeters long, there you go. And so they already show us a picture of what that looks like. So he stacks the cards, and so all of these are 6.3 centimeters long. So he tries leaning the cards against each other so that the angle at the top is 90 degrees. Find the distance between the edges of the cards to the nearest 10. Okay, so when he's asking find the distance between the edges of the card to the nearest 10th, we are looking for this piece right here. All right, so because these two sides are the same, that makes this a 45, 45, 90 triangle. So what I'm going to do is I'm going to make my little table. 45, 45, 90, x, 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 and the square root of 2. And they give us these two, the ones across the 90, because they're the same. Okay. So we already know what these are. Now we're looking for the side across the 90. So instead of x, I'm going to plug in 6.3 and the square root of 2. Okay, so unless this problem tells me to leave it in radical form, I just go ahead and get the square root form of it. So 6.3 times the square root of 2, and this gives us 8.9 centimeters. And that's it. All right, let's look at the next one. So it says Jana is cutting a square of material for a tablecloth. The table's diagonal is 36 inches. She wants the diagonal of the tablecloth to be an extra 10 inches long, so it'll hang over the edges of the table. All right, so they did already put here the 36 inches from here to here. But it says she's going to add an extra 10 inches. Okay, so that means that it's going to be 5 inches on this side and 5 inches on that side. That makes the diagonal 10 inches longer. Okay, that means this entire diagonal from here all the way to here is 46. Okay, and then what size square should Jana cut to make the tablecloth? Okay, so I'm going to go ahead and do the same thing. I'm going to start off by making my table. So I make my 45, 45, 90, x, 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 and the square root of 2. Okay, so the one across my 90-degree angle is the one that they gave us the longest side or hypotenuse. So right there, I'm going to put the 46. So that means x and the square root of 2 equals 46, and we are looking for one of the sides. I'm going to go ahead and solve for x by dividing by the square root of 2. This cancels out. And when I do 46 divided by the square root of 2, that gives me 32.5. It says round to the nearest inch, so 32.5 would be 33 inches. So that they need to make the sides 33 inches each. So there. All right. On the next one, Alex has a square garden in his backyard. If the garden has a diagonal of 18 meters, what is the area of Alex's square garden? Okay, so I'm going to go ahead and make my table. I'm going to make a picture. So this is a garden. It's a square. It says the diagonal, which is this one right here, is 18 meters. And they want us to find the area of the square. All right, well, for area, if we're trying to find the area, we would have to do, those colors do not look good together. Area equals base times height, okay, or length times width. So we need to figure out what is this and what is this. Okay, so this is my right angle. These are my 45s. So that means the 18 is across my 90-degree angle. Okay, so here we have 45, 45, 90, x, 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 and the square root of 2. And so this one is going to be 18. So x in the square root of 2 equals 18. We divide both sides by the square root of 2. And we get x equals, I'm going to put that in my calculator. Remember, with the real world problems, you could just go ahead and leave it in decimal form. So 12.7 is one of the sides. Okay, so 12.7, 12.7. Now we're not done yet because that's not what they're asking us for. They're not asking us for one of the sides. They're asking us for the area. So I'm going to do the area right here. It's going to be area equals base, which is 12.7 times height. It's going to be the exact same thing, also 12.7. And when we go ahead and put that in our calculator, we get 162. And our units are meters Okay. This next one, this one is not a real world problem. So let's go ahead and see. It says the circumference of circle E is 20 pi. Okay. If you don't remember what circumference is the distance around the circle. This part right here. Okay, so that's 20 pi. What is the length of segment DF? So here is DF. We're looking for this. Okay. And then if we notice here, these two are the radius of the circle. Okay. Which are across our 45, 45, 90 triangles. So I'm going to go ahead and make my little table for my 45, 45, 90. X, 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 and the square root of 2. So we need to figure out what these X's are in order for us to find this one, because that's what they're asking for. Okay? All right. So first off, the only information that they tell us is that the whole circle all the way around is 20 pi. So if you remember the formula for the circumference of a circle, it is C equals 2 pi r. Well, the circumference is 20 pi, so instead of C, I'm going to plug in a 20 pi. And then we're going to solve for the radius, okay? And remember, these two little pieces are the radius. So to solve for r, I need to get rid of the 2 pi, so I'm going to go ahead and divide both sides by 2 pi. Here, the pi's cancel out. 20 divided by 2 gives us 10. Oh, whoops, I didn't need to write it twice. It should be equal to r. That's all we have left over on the side, okay? So now, if these two are 10, then that makes this segment DF, so this is 10, this is 10. If our x is 10, then that means that this side is 10 and the square root of 2. So from D to F is 10 and the square root of 2. All right. Let's look at the next one. So here it says find the perimeter of a quadrilateral. WXYZ. Leave your answer in simplest radical form. Okay, so they tell us to find the perimeter. So in case you don't remember, the perimeter is when you add up all the sides. So we don't know what this side is, we're going to have to figure it out. We know this whole thing is 43. We know this is 82. And we don't know what this side is, we're going to have to figure it out also. Okay, so then they give us another piece of information. This is a 45, 45, 90 triangle. Okay, so these two sides should be exactly the same. So let's figure out what those two sides are. So I'm going to set up my table. What the heck? There it is. So it's x, x, x in the square root of 2. Oh, 45, 45, 90. I wrote it backwards. All right, so remember these two are my two legs, and this one is my hypotenuse. Okay, so my two legs, we don't know what they are. That's actually what we're looking for, so I'm going to call this x. Wait, we do have it as x. But this one they do give us. They give us the hypotenuse. They tell us that the hypotenuse is 18 in the square root of 2. So that's what I'm going to write there, 18 in the square root of 2. So what that means is that x in the square root of 2 equals 18 in the square root of 2. So this one's a little bit obvious to figure out what x is. If you're not sure, we can solve for x by dividing by the square root of 2. Cancels out here, and we get x equals 18. This cancels also. So that means these two sides are 18. Okay. So then we are going to use this information. If this is 18 from here to here, that means from here to here is 18. Okay. Now, if from here to here is 18, then we can find just this little section right here by doing 18 minus the 43 minus the 18, which I believe it gives you 15, 25. There you go. Okay, so now we're ready to get the perimeter. The perimeter, we're going to add up all the sides. We have a 25, we have an 18 in the square root of 2, we have a 43, and then we have an 18. Okay. Now we can only combine the like terms, so we can only combine the 25, the 43, and the 18. Okay, we can't combine the 18 because the 18 has a square root of 2 being multiplied with it. So the perimeter of this is, let's see, 25 plus 43 plus 18 gives us 86, and then the 18 in the square root of 2 just stays like that. And I believe they didn't give us any units, so I'm just going to put a U for units. All right. And And the last example, it says find the area of the trapezoid. So here's our trapezoid. We're looking for the area. So for my formula for the area, I'm going to write it down right here. The area is equal to 1/2. You add the bases, base 1 plus base 2. You multiply by the heights. Okay, so let's see what they give us. They give us this is 14 and this is 26, which are both of our bases. Okay, so I already know what those are. All we got to do now is figure out what h is, what the height is. So 26 plus 14, and we need to figure out what that height is to find the area. Okay. Now they do tell us that this is a 45-degree angle. This would be considered my height. And so this would make a 45, 45, 90 triangle. Okay. Now I can figure out what it is from here to here if I just subtract 26 minus the 14, because we know from this base to this base, from here to here is 14. So once I subtract the 26, that gives me 12. That means that piece is 12. And since it's a 45, 45, 90 triangle, that means that is also 12. So the height of our trapezoid is 12. So my area here, I put all that in my calculator exactly the way I see it. And that gives me 240, and our units are centimeters. Since it's area, it is squared. And that's it. Thank you guys. We'll see you next time.